Next, we will discuss the stationary wave in the stretch string. Suppose there are the two fixed ends between which a string is stretched. Simplest case is when there is only one loop, that is, at the fixed end, there will be always a node having the zero amplitude, and in between the nodes, there will be an antinode. So we can say there is only one loop. Further, there may be two loops because fixed end always forms the nodes. So other possibility of the oscillation is there are two loops. That means in between there is one more node, and between two nodes there are antinode. The oscillation may be in three loops or more. Suppose we see three loops, then at fixed end there will be node, and in between these two nodes there are two other nodes, and there are the three loops of oscillation, and between the two nodes there will be an antinode. Similarly, the string may be oscillated n number of loops. L is the length of the string, and if string is oscillating in one loop, the distance between the two successive nodes is lambda by 2. So in first case, suppose wavelength is lambda 1, then it is lambda 1 by 2. In second case, if wavelength is lambda 2, then between the two successive node distance is lambda 2 by 2, and further two other nodes, the distance is again lambda 2 by 2. If in three nodes, we see this is lambda 3 by 2. Lambda 3 is the wavelength of the wave in second case, third case, when the oscillations are in three loops. And again, between two successive node distance is lambda 3 by 2 and lambda 3 by 2. So for n equal to 1, that means number of the loops in the oscillation is 1. We can write lambda 1 by 2 equal to L. This is the length of the string. So lambda 1 equal to 2L, and the frequency in first case will be velocity of the wave divided by the wavelength, that is lambda 1. So it will be V by 2L. This is the equation number 1. Similarly, in second case, where number of loops are 2, we can write that lambda 2 by 2 plus lambda 2 by 2 is equal to L. This implies that lambda 2 equal to 2L by 2, or simply L. Therefore, frequency F2 will be V by lambda 2, because velocity will be same. Velocity in a stretch string is defined as V equal to root T by mu. T is the tension in the string and mu is the mass per unit length of the string. This will be equal to 2 into V by 2L. This is the equation number 2. For oscillation in three loops, the equality will be lambda 3 by 2 plus lambda 3 by 2 plus lambda 3 by 2, because there are the three loops, and it will be equal to the length of the string. So we can write lambda 3 is equal to 2L by 3, and frequency of oscillation will be equal to V by lambda 3, that is equal to 3 into V by 2L. Similarly, we can proceed for n equal to 4, 5, 6 and so on. And in last, if we take n equal to n, then we can write from the analogy that Fn will be equal to V by lambda n, and it will be equal to n into V by 2L. So this will be the frequency of the oscillation if the stretch string is oscillating in the n number of loops. For n equal to 1, frequency F1 is called the fundamental frequency, or first harmonic. For n equal to 2, we have found F2. This is the frequency when the oscillation are in two loop, and it is called the second harmonic. Similarly, F equal to 3 is called the third harmonic, and Fn is called the nth harmonic. Therefore, we can say that even and odd, both harmonics generates in a stretched a string. Let's take some example. First question is, standing waves are produced in 10-meter long stretch string. If string vibrates in 5 segments and wave velocity is 20 meter per second, the frequency is. Because stretch string is oscillating or vibrating in 5 segments, that means number of loops are 5. And for n loops, we know the frequency f equal to n into v by 2l. This formula we have already discussed. Using this formula, the number of segment or loops are 5. Velocity of wave is given 20 meter per second divided by 2 into, and length of the string is given 10 meter. So this 20 get cancelled by 20. So frequency will be 5 hertz. This is the answer. Second question is, a string is cut in 3 parts having the fundamental frequencies n1, n2 and n3 respectively. Then the original fundamental frequency n related by the expression as. It is given that a string is cut in 3 parts. Suppose length of the string is L and length of the 3 parts is L1, L2 and L3. Then L is equal to L1 plus L2 plus L3. Now we know that for a stretch string, if there are the n loops of oscillations, then the frequency is given by n into v by 2l. And for n equal to 1, the fundamental frequency f is equal to v by 2l. This is the formula for the fundamental frequencies. So in first case, n1, this is the first frequency, that is equal to v by 2 into l1, 2 by l1. Similarly, n2, second fundamental frequency for length l2, it is equal to v by 2l2, and n3 is equal to v by 2l3. This is equal to, substituting the value of l1 as v by 2n1. So we can write v by 2n1. Similarly, for L2 we will write v by 2n2, and for L3 v by 2n3. So on right hand side, the common term is v by 2 and remaining is 1 by n1 plus 1 by n2 plus 1 by n3. V by 2 is taken on left hand side, we will have 2l by v, that is equal to 1 by n1 plus 1 by n2 plus 1 by n3. Because total length of the string originally was L, and in this string the fundamental frequency will be v by 2l. This 2l by v is the 1 by n, that is the one of the fundamental frequency of the string length L. So we can replace it by 1 by n, that is equal to 1 by n1 plus 1 by n2 plus 1 by n3. This is the relation required.